Fuses are the simplest of overload devices, constructed of an internal element that will melt if excessive current flows through the circuit it's protecting. Fuses are often used to protect resistive loads which have no coils, such as heaters. Here we see that each of the three heaters have two fuses protecting them. Once the fuse blows, it must be replaced. Overload devices that are used to protect inductive loads, such as motors, are somewhat more complex because the current draw of inductive loads is not always constant. When a motor is initially energized, it draws substantially more current than when the motor is up and running to speed. For example, this motor draws close to 70 amperes when it's first energized. This is the motor's locked rotor amperage. As the motor reaches its design speed, the current draw drops down to its full load amperage. An overload commonly used to protect small motors is the line break overload, which breaks the power line that supplies power to the device. The most common type of line break overload has a bimetal disc that flexes with changes in temperature that result from excessive current flow through the circuit. When the current exceeds the acceptable level, the heat generated will cause a bimetal disc to warp, causing the circuit to open. This will de-energize the circuit. Some line break bimetal overloads are also equipped with devices that sense the surface temperature of the controlled device to provide a more accurate range of circuit protection. The overload is wired in series with the common terminal of the motor as shown in this schematic. The other type of commonly used overload is the pilot duty overload. Unlike the line break overload, the pilot duty overload breaks the control circuit, not the power circuit of the device being controlled. Notice that the overload contacts are located in series with the contactor coil, not the compressor itself. Three common types of pilot duty overload are the current type, the magnetic overload, and the electronic overload. Troubleshooting overload devices is relatively easy since they only have one set of electrical contacts. To do this, an ohm meter is used. With the power disconnected, an overload in a closed position will have a resistance reading of 0 ohms. An overload in the open position will have a resistance reading of infinity. Internal overloads are harder to test. A reading of infinity through a motor winding may mean that the overload is open, or it may be an indication that a motor winding is damaged. For this reason, the compressor should be cool, giving the overload time to reset itself. If the resistance reading is still infinity after the compressor is completely cooled, chances are that the internal overload has failed.